On a textbook page, a geometry problem is just ink. But in the garden of Mathematica, math dictates physical reality. Break the geometric rules here, and you will not survive. Take a look at this square mapped on our coordinate grid. To find the amount of space it takes up, its area, we multiply the base of 4 by its straight perpendicular height of 4, giving us a total area of 16. Now watch what happens when the chaotic skew goblins attack. They physically push the crystal, warping our perfect square into a slanted rhombus. The base is still 4 units long, but notice this new vertical line. The perpendicular height has dropped to 3. Slanting the shape does not change the side lengths, but it does shrink the true height. And because area relies on that straight vertical drop, 4 times 3 shrinks the total area down to 12. To survive geometric traps like this, you cannot rely on the visual length of a slanted side. You must find the true perpendicular height. Leo escapes the goblins only to hit a fork in the crystal maze. He faces 2 massive glowing doors, a rectangle and a triangle, resting on a giant XY coordinate floor. To safely pass, he must choose the gate with the larger area. Look at this coordinate grid mapping the rectangle door. Tracing the grid lines, we see a base of 4 units and a height of 6 units. We multiply 4 by 6, locking in an area of 24 square units for the first gate. Checking the triangle door, its base is 8 units and its perpendicular height is 6. Because a triangle takes up exactly half the space of a matching rectangle, our formula multiplies the base and height, then divides by 2. Applying the correct formula directly to the coordinate data reveals the true size of a shape, regardless of its intimidating appearance. The skew goblins are catching up. Pause the video, calculate the triangle's area, and point to the safe door. First, multiply the base of 8 by the height of 6, giving 48. Then divide in half. The triangle's area is 24. Now we compare them, 24 and 24. Both doors are exactly the same size. Trusting the math formulas over your own eyes reveals that sometimes there are multiple correct paths to solve a problem. Either gate is safe. Deep in the forest of primes, Leo encounters a structural monster, the giant Composite Beast. To defeat it, he must break its large composite number down to its prime core. Using his compass, Leo splits 60 into 6 and 10. The 6 branches into a 2 and a 3, our first primes. The 10 splits into 2 and 5. Combined, the final prime factorization is 2 times 2 times 3 times 5 equals 60. Just as complex geometric shapes are built from basic dimensions like base and height, the largest numbers are built entirely from unbreakable prime factors. Whether you are escaping glowing crystal mazes or fighting towering rock monsters, knowing the unbending rules of mathematics guarantees your survival. This is your ultimate Mathematica survival guide. Take a screenshot of this frame right now and keep it ready for your own adventures. Mastering these geometric dimensions and prime building blocks turns intimidating problems into clear, solvable patterns.